bite to eat and he's rolling. He never changes a thing.
Hey everyone, welcome to today's lesson about solving inequalities. When we solve inequalities, we're going to treat it just like we would an equation. We're going to isolate the variable and use our inverse operations. The only catch is that when we multiply or divide by a negative number, we must switch the inequality. Again, when you multiply or divide by a negative number, you have to switch the inequality. The other difference is that when we solve inequalities, we will always graph on the number line to illustrate the values for which the inequality is true. So, when we are graphing, we will use an open dot for simply greater than or less than, and we'll use a closed dot when we have the or equal to bar underneath the inequality. This shows whether or not the solution is included in the set or not. So let's go ahead and get started with some examples, and we'll talk about some of these rules as we go. Looking at question number 1, I need to isolate the variable b. So I'm going to start by undoing my addition and subtraction by subtracting 45 from both sides. I complete the subtraction, and I'm left with 2b is greater than 16. I then undo my multiplication by dividing both sides by 2, so b is greater than 8. Alright, down here on our number line, I want to make sure I label 0. I want to label 8, and I'm also going to label negative 8 so we can get an idea of where things are lying on the number line. Then, I'm going to put an open dot at 8 and show that all values greater than 8 are included in my solution. That's it. Let's look at example number 2. Before I can begin solving, I need to simplify. I need to use the distributive property. So I'll multiply 2 times x and 2 times 4. Let's rewrite this after I distribute. 3 plus 2x plus 8 is greater than 3. Now I combine my like terms. 3 and 8 are both constants, so 2x plus 11 is greater than 3. Now I go ahead and subtract 11 from both sides. So 2x is greater than negative 8. Divide both sides by 2 to undo that multiplication, and I find that x is greater than negative 4. So I'll move down to my graph. I'll label 0, I'll label 4, and negative 4. Because the inequality is simply greater than, I'm going to put an open circle at negative 4, and I'll shade all values greater than to illustrate the solutions to my inequality. Alright, let's look at a couple more before you get to try. Looking at question 3, I first need to distribute this negative 4. So, negative 4 times 2 is negative 8. Negative 4 times negative x becomes positive 4x, and it's less than or equal to 8. Now I can begin solving. I'm going to add 8 to both sides, because that's the opposite of negative 8. When I complete this addition, the 8's go away. I'm left with 4x is less than or equal to 16. I divide both sides by 4, and x is less than or equal to 4. Now, I did not switch my inequality because I was only simplifying the left side. I did not multiply both sides by a negative. Be very careful with that. Now, time to graph. I'll label 0, I'll label 4, and I'll label -4. Since the inequality symbol is less than or equal to, I will go ahead and put a closed circle at 4, and I'll be shading all of my values that are less than. Also notice that at the end of my graph, I make an arrow so that those values continue on past my number line. All right, looking at question 4. Don't go running, we have fractions. I'm going to show you a little trick to get rid of them. Let's say we were to add all these fractions together. What would my common denominator be? The common denominator between 3 and 2 would be 6. So, I'm going to multiply every term by 6. Something magic is going to happen here. Let's start here. 2/3 times 6. Well, 6 times 2 is 12. Divided by 3 is 4. So I've got 4f. Plus half of 6 is 3. And that's greater than 6 divided by 3, which is 2. Much nicer. All the fractions are gone, and I can begin to solve. I'm going to go ahead and subtract 3 from both sides. I get 4f is greater than -1. I then divide both sides by 4. And I find out that f is greater than -1/4. All right, onto the graph, label your 0. I'll have +1/4 and -1/4. Since the inequality is simply greater than, I'm going to put an open circle at -1/4, and I'm shading all values greater than -1/4. There you have it. Now it's your turn. Try these two questions OYO. For each question, make sure you solve and graph the inequality. Go ahead and pause the video and then check your answers when you're finished. All right. First question, you should have subtracted 8 from both sides to begin with. I'm left with -3y is greater than or equal to 21. I'm dividing by -3. When you hear dividing by negative, you should hear some bells and whistles going off in your head. I need to flip that inequality. So y is less than or equal to -7 now. All right, on to the graph. 0, 7, and -7. I'm going to be putting a closed circle at -7, and y values are less than, so I'm shading all the values less than -7. Last one, let's see how you did. To start off, I need to get this 2 out of the denominator. Everything is being divided by 2, so I need to multiply both sides by -2. Again, you should hear some bells and whistles going off in your head. You've multiplied by a negative. You need to flip that inequality. So what I'm left with is x plus 5 is now less than -6. To finish solving, I need to subtract subtract 5 from both sides. So x is less than -11. Our last graph, put my 0, put my 11, put my -11. I have a less than sign only, so that's an open dot, and I'll be shading all values less than -11. All right, that's it, folks. Hope you learned a little something about solving inequalities. You can put this to use on your next homework assignment. That's all for now.